Today we're going to continue solving quadratics, but a little difference. Notice this is no longer an equal sign. Now it's an inequality. So when you were doing algebra 1, you would have solved inequalities, but none of them had x squared in the problem. So now that we have x squared, that kind of changes the whole game. So we're going to give you a list of steps to follow that way. All those things that go on in the background that you don't see are being acknowledged. So we'll get right into it. The first step is you want to put your problem into standard form. So just like if it said equals, we want it to be 0 on the one side. So we do that real quick. And then what we do is we imagine if we graphed this, it would look like a smiley face, and we need to find the x-intercepts. So those are the most important points when solving inequalities. All right, we also call them zeros as a reminder. And what we're going to do is we're going to just pretend that this problem said equals. So if this said equals and I said solve it, how would you do it? I do tell my students to put this equal sign in quotes because a lot of times if they just write equals, they forget that the problem had an inequality symbol. So I recommend you write the little quotations here so you don't forget that, hey, I'm just pretending it says equals. This can easily be solved by factoring, so that's how we're going to do it really quick. And so you're going to get two answers. You're going to get 4 and you're going to get -1. And that's really what you do for step 2. All right, step 3 is we have to make note that the 4 and the -1, they're not solutions. We don't want to circle them and say we're done. Right? Because it's an inequality problem, we call these critical values. So once you find your critical values, you're going to put them on a number line. So we're going to make a little number line. We're going to put -1 and 4 on it. And then if you can tell, there's 3 sections. There's a left, a middle, and a right. And so sometimes it's nice to name them so you can keep track of them. So I always call them intervals. Some teachers call them regions. It doesn't really matter, but I will call them intervals for my portion of what I teach. So we have 3 different intervals. So that's kind of like a golden step for these problems. That kind of gets you going to the next section of work. So we'll make sure that we put those critical values on a number line and identify our intervals. Step 4, we're going to test each interval. And what I mean is we're going to pick a number that's in each interval and we're going to plug it back into the beginning problem. So you have to pick a point to the left of -1. It can be anything. I'm just going to use -2. You have to pick a point that's between -1 and 4, so I like to use 0. 0 is an easy number. And for interval 3, you have to pick something bigger than 4, so I'll just use 5. And what we're going to do is we're going to take those points and we're going to plug them back into the starting problem. So I know the starting problem had the 4 over here. I like having 0 over here, so I'm just going to use the modified starting problem to do my testing. It's not going to change the outcome. Then we'll have to plug 0 in, and then we'll have to plug 5 in. Okay, so we set up all of our testing, and then we're just going to simply crunch it out. Okay, so if we do -2 squared minus 3 times -2 minus 4, we'll get 6. And then you'll have 6 is less than 0, which is completely false. So our statement that results from our test point is false for the first interval. For the second interval, you'll get -4 is less than 0, which is true. And for the third one, you'll end up getting 6 again over here, and 6 is not less than 0, so that third interval does not work. So I recommend that when you look at your number line, you cross out intervals that were false. So interval 1 was false, interval 2 was true, so I like to circle the true intervals. Interval 3 was false, so I crossed that out. So what this means is all the answers to this problem lie in interval 2. That means if you picked any other number for interval 2, it will work in the inequality. Now there's a lot of numbers between -1 and 4 if you think of decimals, for example. So we're going to represent our solutions using an inequality. So we either set it up like this, where it means you need to pick numbers that are bigger than -1 and also less than 4, or you can also present your answer in interval notation. So numbers between -1 and 4 can go in for x. Now the reason that these are not underlined or that I did not use brackets is because if you use -1 and 4 themselves, you'll get 0. And it says you're supposed to get less than 0. So those cannot count. Right? If this was underlined, then I would change this to brackets, or I would underline my answers here. So I want to do this is the exact same problem we just did, but I want to show you from a graphical standpoint what's going on. So I'm going to borrow my x-intercepts or my critical values from the problem that we already did, and we're going to graph those on our coordinate plane. All right, we don't really need to find h and k, we just need to find the x-intercepts because they control the answers to the problem. So apologize, my graph got a little bit off here. This should be over a little bit, but that's okay, we'll make it work. So I graphed -1, 4, and -4 for the y-intercept. I just like to have a third point, and I knew the y-intercept was -4. And then it's a smiley face, so it's going to dip down and come back up. So that's the picture of the problem, and you have to remember that, if you plug in a number for x, you're going to get an outcome, and those are called y values. So what they're really asking you is, when would your y value be less than 0? Or where in the graph do you see negative y values? Right. So there's 3 sections that this divvies into. Points that are to the left of -1, points in the middle, and points to the right of 4. And that's kind of like your interval 1, interval 2, interval 3. We have a left section of our graph, a middle section, and we have the right section. So what you do is you kind of look at these different sections and you imagine a point in each section. So for example, something to the left of -1 could be like -2. That puts me right here on the parabola. Well, that is not less than 0, so that region fails. If I pick a point that's between -1 and 4, like 2, the y value is negative. That is less than 0, so that region works. And same thing here. If you pick a point to the right of 4, like 5, that's going to put you right here. That y value is greater than 0. So because the middle section is where all my y values are negative, I want to make sure that my x values are between -1 and 4. As long as I use those numbers for x, I will generate a negative y value. So that's graphically what's going on when you do your math. So first things first, we're going to run through our steps again. We're not going to graph it. We're going to use algebra. So we want it to be 0 on the right side. So move that 5 over. And then I would probably just plug this into the quadratic formula because I don't think it's going to factor nice and pretty for us. So we'll go ahead and set up the quadratic formula. And we'll just clean it up a little bit. So we should get 61 as our discriminant. Now we could go ahead and make a number line and use the plus for one of our critical values and the minus for the other. But this is going to be really inconvenient to plug into a calculator. So I'm okay with you rounding it. Just make sure you round it to like 1 or 2 decimal places, not a whole number. That'll make it too hard. So it comes out to about 1.5 and -1.13. So those are the critical values I'll be using. So we could draw our number line. We're going to put those points on our number line. And we're going to pick a number from each interval. So I picked the numbers -2, 0, and 2 as my test points. And then we take each of those points, our test points, and we plug it into either the very beginning problem or the one where we moved it over to make 0. And I will always be using the 0 one. So we got to run through and see if which one of these is true, which one's false. So we'll end up getting true for the first one. We'll get false for the second one. And we'll get true for the third one. So I would circle my interval 1 and 3, but the middle interval failed. So if we don't circle that, we cross it out. And then we have to present our answers. So we can pick anything to the left of negative 1.13. We can also use that number itself because we're allowed to actually get 0 as an answer. So we want to make sure we underline. We can also pick numbers to the right of 1.5. And again, we can include 1.5 because you're allowed to get exactly 0. If you choose to go with interval notation, you want to make sure you use a bracket on your critical values because they are allowed to be included as answers this time. And we also need a U to show that, oh, you know what, there's a break in that. The middle section doesn't count, so we have to break it up. Now, if you were to graph the parabola, so if you typed this into Desmos and you graphed it, it would be a frowny face. You can see your x-intercepts. And they want to know, when is your frowny face below or touching 0? So the middle section is clearly above 0, so that section's out. But the left section and the right section all dive into the negatives. So those are my solution regions.